Today we're going to continue Unit 4, Lesson 2. So in the first part of Unit 4, Lesson 2, we were writing equations based on graphs. We were looking for the slope and the y-intercept and writing equations based on those. Remember, the equation of a line is written as y equals mx plus b. When we're writing equations from tables, we're going to do this a little bit differently because when you see these type of problems, you'll often see them as a multiple choice question. So we'll use the choices that they give us, the answer choices they give us, to help us, instead of coming up with the equation on our own, we'll use those answer choices they give us and test to see which ones are correct. So we have the different steps for what we do to match a table to its equation. The first step says to plug in your x and your y values into each equation and see if it makes the equation true. What does that mean if the equation is true? The left side of the equation is equal to the right side. When you find an equation that works, try a few points, so try at least 2 points just to be sure. So what does that mean? Let's look at our question over here to the right. Notice we have x values and their corresponding y values. And then we have 4 different answer choices for equations. We want to match the equation to the table. So what you're going to do is choose an x and a y. So you have to choose a corresponding x and y, so any two that are right next to each other. In this case, when x is 12, y is 9, you can choose that point. You can choose 13 and 10, 14, 11, any one of these two, but you have to choose corresponding x and y values, which in this case, they're right next to each other. They'll either be right next to each other, or if the table goes this way, they'll be one on top of the other. But we'll look at an example like that in a minute. So notice 12 is in the x column, 9 is in the y column. So we'll plug in 12 for x and 9 for y. We'll start with the first equation, just because it gives us somewhere to start. You can really start with any equation you'd like. So y equals x plus 3. We're going to replace x with 12 and y with 9. So what does that look like? 9 equals 12 plus 3. Notice I replace y with 9 and I replace x with 12. Now we plugged in, we want to see if it makes the equation true. Is the left side equal to the right side? Well, the left side is 9. 12 plus 3 gives you 15. Does 9 equal 15? No. So that means option 1 can't be an answer. The moment you find an equation or a point that makes an equation not true, that cannot be the answer. So let's try the next equation. We have y equals x divided by 3. We can use that same point or a different point, it doesn't matter. But for some consistency, we'll use the same point. We'll replace our y with 9 again, and we'll replace x with 12. So we plugged in. Now we want to see if the left side is equal to the right side. The left side of our equal sign is 9. The right side says 12 divided by 3, which is 4. Does 9 equal 4? Nope. So that cannot be our answer. That can't be our equation. Let's try the next equation. Y equals 3x. Now, again, you can choose another point or use the same point. It doesn't matter. We'll replace 9. In this case, we'll use the same point. So we'll replace y with 9 and x with 12. What operation is happening with the 3 and the x right here? I notice the 3 and the x are attached to each other. What operation is that? That's multiplication. So we'll do 3 times 12. Now we see is the right side equal to the left side? 9 is equal to 3 times 12 is 36. That is not true. 9 is not equal to 36. So that cannot be our equation. Hopefully then the last equation works. Let's try this. Y equals x minus 3. Again, you can choose any point or plug in the same one. We'll use the same one, replace y with 9 and x with 12. Now let's see if both sides are equal. 12 minus 3 gives you 9, so 9 equals 9. That is true. Now remember, when you come across one point that works, try at least 2 to make sure. So let's pick another point. It can be any point. Let's choose this one. And we're going to plug it into that same equation. I'll move down here. Y equals x minus 3. Now this time we'll replace y with our new y, which is 11. And we'll replace x with our new x, which is 14. So is the left side equal to the right side? The left side is 11. The right side says 14 minus 3, which is 11. 11 equals 11. That is true. So that means that last equation works. That means the equation for this table is y equals x minus 3. So just to recap what we did, to decide which equation matches the table, we picked a point to plug in. Each point gave us an x, or this point gave us an x value and a y value. We replaced the x and the y into each equation, and what we wanted to do is see if it made the equation true. If an equation is true, the left side is equal to the right side. If both sides are not equal, then that is not the equation, so you move on to the next one. The moment you find a point that works, you try another point from the table in the same equation just to make sure. Like we did here, we plugged in 12 and 9. It worked, so we tried again with another point just to be sure, and that point worked as well. So that is our answer. Let's take a look at this next problem. Same question, what is the equation of the linear function modeled by this table? So again, our first step, what we're going to do is we're going to pick an x and a y, corresponding x and y, and then we're going to plug in. You want to see if the x and the y value make the equation true. How will you know if the equation is true? The equation is true when the left side equals the right side. So let's pick any point. Now this table is different. Notice how it's running horizontally. That means now when we choose an x value, let's choose this 3. You choose the y value attached below it, that is 0. So we're going to plug that 3 for x, 0 for y. We'll start with the first equation and see if it makes it true. So we have y equals 3x minus 9. What will we replace y with? Well, we chose this point here, so what will we plug in for y? 0. So we have 0 equals 3, and what will we replace x with? 3. Now remember, the 3 and the x are stuck together. That operation is multiplication, so we're doing 3 times 3, and then subtracting 9. So now we want to see if the left side is equal to the right side. Our left side is 0. Our right side says 3 times 3 minus 9. Well, 3 times 3 is 9. So now we have 0 equals 9 minus 9 is 0. Look, left side equals the right side. That's true. Got it on the first try. But we're not done. We need to pick another point just to be sure. So let's pick another point. Let's pick this one. When x is 5 and y is 6. We're going to plug that into the same equation just to be sure. So we'll replace y this time with 6. And what will we replace x with? 5. What operation is happening here with the 3 and the x? That's multiplication, so we'll do 3 times 5 minus 9. Now that we've plugged in our numbers, we want to make sure the left side is equal to the right side. So our left side is equal to 6. 3 times 5 is 15 minus 9. So left side is still equal to 6. 15 minus 9 gives you 6. Left side is equal to the right side. We found 2 points that work for that equation. So you can circle that as your answer. So again, to recap, we picked a point and we plugged it into an equation. We replaced the x and the y, and we wanted the left side to equal the right side. When you found one that worked, you tried another point just to be sure. But if that first point you plugged in didn't work, then cross out that answer, move on to the next equation and try that one. So these questions are a matter of plugging in and looking for the answers. You're using the answers that they give you, the answer choices they give you, to help instead of coming up with the equations on your own.